I was in on a photo shoot in Greenwich, Connecticut, and they were actually pouring the gypcrete floor, and all of a sudden I hear the guy screaming. It's because it was leaking around the toilet flange and pouring into the basement, and I just hear these guys start cussing. So we're at the International Builder Show for the second day. Today we are recording a podcast with Rob Wadsack, digital brand manager, Terry Alsberg from Warmboard, and Mike Guertin, longtime contributor and our editorial advisor. What do you guys think about the show so far?
Oh, I'm exhausted. I spent all day yesterday. Well, actually, I started out weeks before the show, and I made up because there are 1,540 exhibitors at this show.
So what are you looking for ahead of time? Stuff that you haven't seen.
Stuff that I haven't seen, or stuff that I've seen before, but haven't gone back to look at in years. Because a lot of these manufacturers tweak things, change things, whatever. And I want to just, check in with companies I haven't checked in with a while.
Sure.
And I did that yesterday. A couple like pressed-on pressed-on products. They make drywall clips for doing butt joints.
To eliminate framing members.
Exactly. And I was like, okay, what's new and different? Well, everything's the same. And I went, I was talking
around.
Well, as I talking with him more, he said, well, 3 years ago we bent these little tabs on the clips. And that causes the butt joint to kick in about 1 degree. And that way, when you set the tape, you bed the tape, it's a recess, like a taper joint, and now it's flush. So, nice. So I make up my list, and then I walk up and down the aisles, just basically ignoring everybody else.
I try and do that too. I actually pull off the press ribbon that's on my badge, so people don't And
having a regular attendee badge is like gold. Yeah.
So Terry, you come to the show, do you have a booth here at your company?
Yes, we do.
And what is your hope when you come to the Builder Show?
Well, we haven't been to the Builder Show for a few years now because we don't find that Builder Shows are really the best way to market anymore. They're quite expensive to do, and the results haven't been really a good return on investment for us. We decided to break the trend this year because we're introducing a new suite of components which we call the Warmboard Comfort System.
What's that?
Well, in the past, Warmboard's been just
We should tell people what Warmboard is probably to start with. Can you give me a little explanation?
Warmboard is a panel that I invented. It's a 4x8 sheet of tongue and groove plywood. It's 1 1/8 thick, the primary panel. We have 2 panels, but let's talk about the flagship panel.
Please.
So it's 1 1/2 thick of 7-layer Doug fir plywood. We route a pattern of grooves in the top surface of it. We stamp a sheet of aluminum to match the groove pattern. We bond it to the plywood permanently. And so now when you frame your house, instead of framing it with ordinary subfloor, you frame it with Warmboard as a structural subfloor. And so instead of looking out over a sea of Doug fir plywood, you look at it a sea of green painted aluminum faced plywood.
And then people put partition walls over top of your
yes,
subfloor?
Yes, absolutely.
And you make these custom for the structure, but the panels come in some standard shapes. Is that correct?
Yes, we have 4 panel types. There's 3 kinds of turn panels and 1 straight panel. And think of them as Legos. You can take a box full of Legos and build pretty much anything. You can go down to a lumber yard and buy boxes full of 4x8 sheets of this and 2x this and 4x this and et cetera, et cetera. And I'm always amazed as an architect that, it's just like Legos. The conventional platform frame construction allows you to build almost any amazing shape out of fundamentally conventional objects.
Simple shapes.
Exactly. And so the idea behind Warmboard was that it should be compatible with Western platform frame construction, which is the system that we use here in North America. And the term platform frame construction refers to the importance of the platform, the subfloor in a house. And we are the subfloor. And so we are right at the core of what makes modern framing efficient.
So the panels are installed by carpenters,
yes,
not the heating and HVAC contractor, right?
It's usually put in by framers. It cuts with a skill saw, it nails with a nail gun. You typically will put some panel adhesive on the top of the joist before you stick it down. And you stagger them just as you do a typical subfloor pattern. And in most respects, it's just like subfloor as far as the carpenters are concerned. And we supply a complete set of documents for every house.
That show the layout of the panels,
exactly,
right?
Because it's very important that the panels be laid out correctly if you're going to end up with the right loop patterns.
You want the right loop patterns to provide the appropriate amount of heat to the size of the space or whatever considerations
Yes, for those people not familiar with radiant heat, it's typically done with tubing, and the universal tubing used is called PEX tubing. It stands for cross-linked polyethylene tubing. And so you press the tubing into these grooves in typically lengths of 250 feet or less. So if you have a 1,200 square foot house, 3,000 square foot house would have roughly 12 loops in it. Mm-hmm. And the loop patterns then need to be set by the panels. So you look at our drawing to set the loop patterns, and if you do it right, then it's very, very easy to install the tube. You just press it into the tube. It's either done with a roller or people walk it in. There's a variety of ways to do it.
That's what I saw him do on the project we were working on.
What was your experience with this, Mike?
So I didn't install it. Mm-hmm. Some other crew had framed the house and it had the panels in there already. And we were doing the siding and installing the windows. So we just watched what the the plumber was doing. Basically, it was a plumber boiler installer.
Was it easy to get the tubes in the panels?
He'd done it before, so he was very familiar with it. So he just walked them in real quick, and then he had a stand-up roller, which was nothing more than it was like a vinyl flooring roller.
Yeah, like 90 pounds, right?
Yeah, it was whatever it weighed, and he just, after he stepped it in, he just rolled it in, and he cranked that out, and it was amazing, because I've seen him do staple down, and it takes a lot longer to do the staple down than because they have to follow, snap the lines, organize the whole thing.
So we were talking last night, and more commonly, in-floor radiant heat is either done staple up underneath the floor, right? So you put it on the bottom side of the conventional subfloor, right? Or you put it in a gypsum layer, gypsum
thin slab.
Yeah, yep. But it's not concrete, it's gypsum, right?
Yeah, it's a gypsum concrete. It's usually poured 1.5 inches thick.
And so what makes your product better than those methods that listeners might be more familiar with?
Well, the job of a radiant panel is very simple. You conduct heat from water in a tube to the surface of the floor, period, end of sentence. It's a conductor. That's its only role. There's a reason why frying pans are made out of aluminum and not concrete.
Do you have a concrete frying pan?
Well, I had to get rid of it because I was having trouble cooking my eggs.
I got a concrete boat, but not a concrete frying pan.
I first encountered radiant as an architect. Some customers, clients requested it, and I did it in the conventional fashion. I used gypcrete. And I'm a California architect, which is a seismic zone 4, and I want to tell you, put 15 pounds per square foot of dead load into a building, and it's a non-trivial structural problem for an earthquake-resistant house in California.
Because that weight is going to want to move around in a seismic event.
And the higher up in the building, the second floor is worse than the first floor, and the load just got kind of built up.
So you came up with this product to solve that problem?
No, really. I was going to remodel my own house. I have 2 kids with asthma, and I had read extensively on the advantages of radiant. There are many, many advantages. One of them is for people with allergies, because the air is just simply much cleaner because you're not
blowing it around.
We sometimes call forced air systems forced hot dust systems, is what they are.
Yeah.
And so with a radiant system, you're not aerosoling the dust and re-aerosoling them constantly. The air is very still. The dust settles out. You vacuum it up. Your house stays clean.
Do you have radiant in your house, Mike?
No.
Do you wish you
did? I wish
did?
I did, yeah.
Yeah. Why?
I've installed it in lots of other customers' houses, but not in my own.
And what do they like about it? What is it that people seek it out for?
Comfort. It just really comes down to comfort. I mean, yeah.
And you were talking a little bit about that earlier. Forced air systems, by their nature, have a stratification of temperature in rooms. Is that correct?
Correct, yes. I mean, people think that heat rises, as they tell people. No, heat doesn't rise. Hot air rises. And so air comes out of a forced air register typically about 140 degrees or so. That's very buoyant air, and it's going to make a beeline to the ceiling. And it's going to make the spiders up there and the cobwebs very warm and comfortable. Meanwhile, your toddlers are crawling around on a 68-degree floor.
My floor is I've measured it with an IR thermometer. It's commonly 64 degrees.
Yeah, even worse.
And it's cold.
Even worse. That's nasty cold.
Yeah.
Yeah. Floors in my house are typically about 78 degrees. And by the way, people want to come over to my house and feel the radiant. And I tell them, you're going to find it very unremarkable.
Yeah.
Because your skin temperature is about 86 degrees or so. When you're walking around on a 78-degree floor, it does not feel warm at all.
It just feels
It doesn't feel
normal.
cool either.
Yeah,
it feels
like
neutral.
It should. Yeah.
You don't notice it.
Yeah.
I always tell people that you notice your cruel shoes when you have them on. You can't wait to take them off. Right? The thing about comfort is best described as the absence of discomfort. So
it's unremarkable.
Yeah, so when you got your comfy shoes on, you forget you have shoes on. When you live in a radiant home, you forget you have a heating system. You walk around in every room of the house. It's invisible. It's silent. There's no noticeable thing that draws your attention to it other than the fact you notice, if you think about it at all, gee, I happen to feel pretty comfortable.
I don't mind this space.
And when you feel comfortable, you take no note of it.
So in a recent podcast, we had a conversation about a low-load home, right? And the expectation oftentimes amongst homeowners with radiant floors is that they're going to feel hot. They're going to feel warm. And that's not the case. That's what you're alluding to.
Well, we don't even want to get the floors hot. If you notice the floors being hot, you've got a bad system.
Or you've got a bad house.
Yeah, but according to RPA guidelines, and this came from a European study, you don't want to heat a radiant home floor above 85 degrees. Now, 85 degrees feels subtly warm. Mm-hmm. I talk a lot to there's two halves of our industry. There's floor warming, which most people are very familiar with. That's where you do it in a bathroom, typically with electric mats underneath tile. And people like that because it's nice to get out of the shower on warm tiles. And I often tell people, gee, if you like getting out of the shower on warm tiles, imagine walking throughout your entire house on a nice warm floor. We want to have that sensation every place. But when you talk to the people that do the floor warming, their goal is to have the floor between 81 and 84 degrees. And they find if they don't heat the floor to about 80 or 81 degrees...
No one notices.
Well, they're unhappy because they paid for this system. Sure. And they say, and I don't feel it, right? Yeah. And yet, it's doing its job of heating a house. It doesn't take... Basically, a radiant floor works just like a wall radiator, except a wall radiator is a very small area, so it has to get very hot. A radiant system is a very large area, so it doesn't have to get very hot. And so we transfer enough heat into the house at very mild floor temperatures. And it's those mild floor temperatures that it's the essence of the comfort. So anyhow, I was remodeling my own house. And I had a home office as an architect. It was going to be my sample bag. I wanted to have all the really nice architectural features in it. My clients would come by, go to my home office, and see it. And I had these asthmatic kids, and so I was going to put radiant in it. But it was a beach home in California, and it had redwood, 2x4 redwood floor joists. And
you said 2x4?
I'm sorry, 2x6.
Okay.
And redwood is not near the strength of Doug fir, and it was not going to take the 15 pounds per square foot dead load. And I knew that other people, I wasn't the first person to think to use aluminum. Right. They had been done before. There are emission plates and the various aluminum concoctions that radiant is used for, but they're very labor intensive. And it's just a lot of assembly to get these things done. And my father used to tell me the best engineer is a lazy man, just trying to find an easier way to do something. I'm a very lazy man. And
I don't believe anyone who's a business owner is a lazy person.
Well, up to a point. I mean, there are limitations. But in any case, so I decided to find an easier way to do it. And I was doodling on my drafting table one afternoon. I was wondering if I could get a 4x8 sheet of plywood that would have a pattern of grooves in it that I could cut with a CNC router. Sure. And frame my house for it and get all the loop patterns I needed. And literally just sketching for about 15 minutes, doodling on my drafting table, and I came up with a design that is essentially has not changed a bit in 20 years with Warmboard. And I got it right the first time. And I didn't think that it was worth anything other than doing my own house. My father happens to have a number of patents. And he said, it looks like a patentable idea. He was retired. He says, let me go do a search on it. And we sought a patent out, and now we got it. And the result is that we never intended to be in this business, but I kind of fell into it. And the thing that makes Warmboard better than, I would say, and I think the science holds up, better than all other radiant systems is that if the job of a radiant panel is to conduct, we conduct better than any other radiant panel. We are 5 times as conductive as a gypsum panel. That's not 5% better. That's not 50% better. That's 500% better. It's rare that you get to make a choice in buying a building product that's 500% better than the alternative.
What is the trade-off? Is it more expensive than a gypcrete system? Like, why isn't this everywhere? Why don't I see it on every radiant floor install?
Well, contractors are perfectly willing to try something new and innovative so long as their grandfather used it. Yeah. And that's a big part of it. And the reason why we use gypcrete, honestly, is 2,000-year-old technology. The Romans invented radiant heat. Actually, simultaneously in the Far East, the Koreans were doing it also. Romans called their systems hypocaust systems, which means to burn under, and the Koreans called theirs ondol systems, which means hot stone. And they would have stone slab floors with a cavity underneath it. They would direct flue gases underneath the stone slab floor, and then up through flues in the wall. That would heat the stone, and that would heat the fancy Roman house or baths. Almost all the Roman baths had these hypocaust systems in them. And it was good that they used a stone because it was not particularly conductive, so you don't want to have that hot fire underneath the conductive surface. You're walking around on a pancake griddle. And the fact that it had high mass was a good thing also, because the fires would burn hot and cold, and the flywheel effect of the mass would dampen out the variation in floor temperatures. And so that happened 2,000 years ago, and then the technology disappeared from the world. Then it kind of got rediscovered in England back in the 1800s, because there's a lot of Roman construction in England. You go down to Bathing, and you'll see a really good example of the Roman baths down there. And so they tried to mimic what they saw in the Roman construction, only instead of using slabs with fires underneath it, they used concrete slabs with iron pipe inside of it. And
what could go wrong there?
Yeah, what could possibly go wrong?
Go ahead, Mike. You were going to ask a question.
How did you know that? You're right.
He's known you long enough. He can read your mind.
Go for it.
No, so you mentioned earlier about low-load homes,
right,
and the discussion that you had about those and the use of radiant heat. And I was curious, when you talk about like an embedded system with gypcrete or concrete versus the Warmboard, are there different performance qualities that might benefit using it in a low-load home?
Well, conductivity does a lot of good things. As conductivity goes up, water temperature can go down. As conductivity goes up, the tubing can be more widely spaced. And the reason why we pick any particular spacing for a radiant system is because the temperature always falls off between the tubes. It's straight thermodynamics. You know, it's going to be a little cooler halfway between two tubes than right on top of them. And you don't want to be able to feel that with your feet. And so that's called striping. If you can walk around on the floor, you can feel hot, cold areas. But when you have a gypcrete system and it's a low-load system, then wherever it's going to put out heat, it's going to be a very narrow stripe with some very mild heat and then a cold area in between. And so the striping will get more extreme as you get down to the lower loads of it, and especially when you consider the low conductivity of gypcrete. It's just not a very good conductor. And when you have a system like Warmboard, which is highly conductive, we find that the drop-off between tubes is about, well, if it's a carpeted area, we get about a 1 degree drop between dead center on top of the tube and halfway in between. In a tile area, it's about 2 degrees. In a hardwood area, on a hardwood, it's about 2 degrees. And in tile, it's about 3 degrees. And this is interesting because you hear the carpet's a no-no in radiant. We actually get our best performance out of carpet. We get the most even floor temperatures because aluminum has two great properties. It's highly conductive and it's highly emissive. Emissive is the ability of a material to emit infrared. And so if you didn't have any floor covering on top of the Warmboard at all the heat would be given up within about an inch of the tube, and then in between the tubes it would be at ambient temperature.
That's really interesting. What question do you have?
What question do I have? I guess, what are the challenges and conditions that are ideal for installing a radiant floor? Because I imagine, I think you were alluding to my old leaky house. Maybe
right. You want a lot of heat.
I've got an 1870s house with not enough insulation in it. Would I be better off investing in my insulation before I considered a system like radiant?
Well, you need to do both. We're really only half of a heating system. The other half of the heating system is your infiltration, exfiltration controls, your insulated envelope.
The building envelope,
so
like everybody.
It's a truism in all heating systems. Heat supplied must equal heat lost. Mm-hmm. So if your heat loss is high, heat supplied must be high. It's axiomatic.
Sure.
So if you've got a very high heat loss, we can put out up to 30 BTUs per square foot, which is an extraordinary amount of heat. Most houses in North America are 15 to 25 BTUs per square foot, almost no matter where they're built. Oddly enough, we get some of the highest heat loads in California. And the reason why is because weather's so nice there, the views are so nice, lots and lots of glass, right?
Yeah.
You build in Minnesota,
you don't have windows in
R30
Minnesota.
walls,
Yeah.
triple glazed windows, and your heat losses are actually lower in Minnesota than they are in California.
That's interesting. I hadn't even considered that.
So
part.
in the house that you saw this installed in, what were the floor coverings? Because that's always the question I have, that the gypsum products are very difficult to put flooring on, right? You got to glue it, or what
These
did
are
they
all hardwoods.
And you
And
can
they
actually
could
see your
nail
tubes,
right
right,
down.
Terry?
Yeah, with Warmboard,
You don't have to worry about hitting them.
Exactly.
I got lucky, in a lot of respects, because I chose inch and an eighth subfloor because it happens to have enough meat underneath where you cut the grooves for the tubes to maintain the structure as a structural subfloor. Well, if you look at the hardwood the National Wood Flooring Association, they don't think that nailing hardwood into 3/4 inch subfloor is a good idea. And if you've ever been below a house that has 3/4 inch subfloor and hardwood installed on it, you see all the nails sticking out down below. If a nail,
what do they want you to use?
And a nail, they want you to use either 2 layers of 5/8 or 1 1/8.
Really? Have you heard this?
We can talk about it later because I've been over to their booth talking to their technical guy, and I've got a whole bunch of information.
I've never heard this. I've never heard this.
No, but think about it. If a nail's tip is in air, it's doing nothing. Nail pull-out
Oh, no,
strength
I get
is
that.
it's why we put nails into things so we can't pull them out.
Right.
And so when you use 1 1/8 as Warmboard is, you have not only is it nice for the structural aspects, but it's a great nailing membrane. In fact, we see a non-trivial number of people that use Warmboard on top of concrete slabs, even though they don't need the structure of the Warmboard.
What's the rationale for that?
Because, well, for one thing, concrete slabs are incredibly slow to respond. If you have a night, let's say you have a vacation setback.
Yeah, it's going to take days for that to
literally
get,
2 or 3 days to get the house warm. And so if they want a fast response system, they want to decouple the radiant system from that huge mass.
Thermal mass.
Because it's not only the mass of the slab, it's also attached to sand and gravel and
The
soil.
dirt, yeah.
You know, and if you've got subsurface water, that's wicking away heat also. They've got another problem with that. So the idea of isolating the radiant panel from the concrete slab is a good idea. So, and they do that to get the fast response, and it turns out you can now nail hardwood to it because the nails are not going to stick into the concrete because you have 1 1/8 depth, and your nails go in nicely.
What about tile?
Tile, we tell people, we get my throwaway answer to all contractor questions on Warmboard is it's conventional construction. Anything you would do on any other subfloor, you do exactly the same way on top of Warmboard. So if it's tile, in my house I have 7/8 dry pack mortar beds because I had an old tile setter and that's how we did it.
Yeah.
But probably most of our houses use backer board. It's going to be Durarock, Hardybacker, Wonderboard, one of those kinds of products. Yeah. And the aluminum that we put on our panel is bonded tenaciously to that wood, and the APA that regulates our manufacturing, they come in and do failure tests randomly, and they peel the aluminum off the surface of the wood. It always shreds the wood. The glue is stronger than the wood. And then the paint that we paint it with, well, we do a lot of things to make the aluminum bright. We buy, first of all, very high-grade aluminum.
Why? What difference does it make? Is it better at is that better emissive?
We originally selected, we used the 1000 series alloys. We used 1070, which means 99.7% pure aluminum, and it's very malleable. And in order to stamp our panels, that we're really stretching the heck out of that aluminum, and we need very malleable aluminum. So that's the number one reason why we bought it. But it turns out it's also the most conductive alloy because the 1070 alloy is as much as 30% more conductive than the 3000 or 5000 series alloys. It's a big difference because it's essentially pure aluminum. But it's very hard to stick things to aluminum. So we take that aluminum, we roll it, and then we coat it with chromate. We treat it with chromate, which is what you have to do to aluminum to stick things to it.
What is chromium?
It's called chromate.
Is it a chromium or alloy?
I'm sure it has a chromium atom in the molecule someplace, but it's the proprietary stuff we use is called Aladyne. There's a system that's used. We use the Aladyne chromate treatment. So we Aladyne treat top and bottom of the aluminum. The bottom side, we then put an epoxy backer on it because the epoxy sticks to the Aladyne, which sticks to the aluminum. And then we can use our reactive hot melt to stick that to the wood. So it's a multi-layer. It's a fairly sophisticated process.
Did you know you were going to be a composite engineer when you started down this path?
Actually, before I was an architect, I was a boat builder. I built ultra-high performance,
very high-tech. So you knew about a lot of these laminations.
I know a lot about epoxies and vinyl esters and all the exotic stuff, that kind of thing. And also, before I was in architecture, I was in engineering physics, so I have kind of a background in science. My father was an engineer, and I worked at Bell Labs, and I have that in my bloodstream.
That makes a big difference because we've seen a lot of people who design or engineer a new product, and there are failure points because they haven't thought it all through. Right. You had the technical background to be able to anticipate a lot of the things you needed to design in, because your panels haven't had failures from day one.
Yeah, most architects don't do their own structural analysis. I always did my own structural analysis. It's just like I was kind of a math guy, So.
So as an aside, if the architect's not doing the structural analysis, who is?
Yeah, typically a structural engineer.
That'd be common in California, but I can't imagine that would be common in where we are, Mike, right?
In New York, I saw that quite a bit.
Wow.
Yeah.
You'll see a lot of it, and actually, in most houses, you won't see a mechanical engineer designing heating systems, but in New York, you see a lot of mechanical engineers. And by the way, no offense to mechanical engineers, they know lots and lots about designing ductwork and blowers, but they know very little about radiant. And whenever I'm meeting with a mechanical engineer, I have to teach them what
do they
radiant's
get wrong?
about. They don't understand the limitations of it or the lack thereof. They sometimes think it has higher limitations than it does.
Like what?
They're confused about tubing lengths. They're confused about tubing spacing. They don't understand why you do a particular tubing spacing. And tubing spacing is
How can they not understand that?
because it's not their business to. You know, it's my business too. And I can bore you to tears, trust me, about minutia of radiant heat that
Sound
I've
like my
obsessed
kind of guy.
about. I've obsessed about for 25 years now. And I invented the product 26 years ago.
So how's it doing?
Well, we are the largest supplier of wood and aluminum panels in North America, of those kinds of radiant panels. Of all our competitors, I don't want to mention their names here, but you can go around the show here and see some of them, and all our sales equal theirs all combined.
So if somebody is considering one of your floors on a new build or an extensive remodel or an addition or what have you, like what is their course of action? How do you find out? How do you get it?
Well, I often tell people that it wasn't enough to invent Warmboard. I had to invent a business model to get it to market. And we initially at one time we were a division of Guertin. I'm sure you're familiar with them.
Who?
Guertin, yeah. And they're great people. They're great people. They were great partners, and they had the license to my product. But, you know, when all you've got is a hammer, everything looks like a nail.
Or a window.
Yeah, exactly. And it looks like a window. Yeah. So they thought they would sell it just like through all their window distributors and stuff like that. And those people didn't know anything about heating or framing or any of that kind of stuff.
It's a totally different animal.
And I was reading a book called Dell Direct by Michael Dell about how he was selling computers out of his dorm room at the University of Texas. And I thought, we should sell this direct. Nobody was doing this in the building industry. So we built a direct model. And
so you would just go bang on GC's doors and say, look, we got this new product?
GCs and architects, primarily big-time architects, because it's part of the inherent structure of the product, it needs to be designed in from the very start, from the earliest conceptual drawings. And so it's our jobs and my salesmen's jobs to be good in an architect's conference room. That's what I tell them every day. I said, you need to be good in an architect's conference room. And if the architect specifies it in, and we do copious plans to go along with one of our projects, so you'll get with.
Do you size the equipment too?
Huh?
Do you size the equipment?
We didn't used to, but that's what I want to talk about a little bit today, because we've been talking about the panel, and I'm going to go on and on about the panel and waste several hours of your time on the panel.
You don't have several hours.
Yeah, if I don't. So let's cut to the chase. So we built this great business model. I invented it 26 years ago. We are now the largest. We've done 30 million square feet of Warmboard in North America, and we're around the world too. We do Japan, Australia. We've done Antarctica. We do 2 projects in Antarctica. If you think you can't heat the cold climate, you can heat with, so long as your heat loss is good.
Yeah.
They insulate their buildings very well down there.
You'd have
full
to,
disclosure.
or you'd die.
Yeah, but they do heat it with radiant heat down there. We did one project they liked it so much they reordered, and we did another project with them down there.
And I imagine in that environment, it's pretty installer friendly versus like pouring concrete.
Well, that was one of the reasons. I like to say it was our great thermodynamics, but honestly, it's tough to put a ready-mix truck on a C-130,
Yeah.
whereas you can put
or you start mixing bags.
You can put pallets of Warmboard on a C-130.
Sorry to interrupt you. So about the equipment, who does that part of the job?
Well, in the past, it's always been somebody else. And if you've ever seen radiant heat, you have a boiler, a water heater, or a heat pump, or something that generates
something that makes hot water.
Something that makes water hot. Could any number of ways to do that. And then you have a wall of copper, and we call it the wall of shame.
Come on, that's what plumbers are so proud about.
We have an internal word. We call it boiler room porn, because
that's what you all show your friends.
The plumber gets very excited when he sees it. He gets all hot and bothered when he sees that. Looks like he's putting his kid through college and he can get his Porsche repaired. You know, and so that's how it has been done. But that's been one of the big obstacles to the broad acceptance of radiant in North America. In Europe, 30% of all new construction is radiant. In Switzerland, Germany, and Scandinavia, it's 80%. In Korea, it's over 90%. But in North America, it's 2%. And the reason why is people just are used to forced air. They accept it.
Well, it also
they
makes
deal
air
with the noise.
conditioning. There's some advantages.
Yeah, but we can talk about air conditioning a little bit, and I do want to talk about that. But in any case, so they tolerate it. It's just like, why do women wear cruel shoes? Because they tolerate it, but they can't wait to take them off, and when they have the comfortable shoes on, they're very delighted. So in any case, that's how it's been done, and it's been very expensive. Over half the cost of any radiant system is what the plumber charges, and most of it is labor, and the labor walks off the job. It does not stay in your house. The copper and the valves stay there, but the labor's gone. It's not an intrinsic value to your house anymore. And so I decided to change everything. And we came up with a complete suite of components. We call it the Warmboard comfort system. It begins with a very elegant thermostat. We like to think it's the loveliest thermostat. I should have brought one here to show on the camera. But
I'm disappointed you didn't.
Yeah, I know. I was thinking about having my wife go over and grab one from the booth, but
and then
our architects like to not see thermostats. More and more, they like to hide them. They put sensors in walls, and then you get on your iPhone to adjust them and things like that. But the very popular thermostats these days are Nest and Ecobee, and they're big black carbuncles on your wall, and they just...
You are the only person besides my wife that I've heard use the word carbuncle. I got to compliment you on that.
All right. In any case...
You know what that is? It's a big wart.
Yeah, it's a big pussy sore.
Or a big gem, I think.
Yeah, exactly.
Is the more modern.
Yeah, exactly. In any case, so... the term architecture is called designing in the vernacular, which are familiar forms that we're used to seeing. So this thermostat is very thin. It's thinner than an iPhone. And it is the same height and width as a Decora switch plate, which we see throughout our houses, both for light switches and outlets. So it kind of it hides in plain sight. And it's got an e-ink display on it, so it doesn't need any illumination to be read. And it's very, very high resolution, displays nice fonts, and it displays text. So that we wanted to have the thermostat that you didn't need to have a manual in that kitchen drawer. That kitchen drawer everybody has, where all the crap is? Yeah. Well, there won't be a manual with Warmboard. It's all right on the screen. I was trying to
turn off the check filter on my thermostat recently, and I couldn't figure out how to turn it off. So I put some tape over it.
You walk up to it, you tap it, it's a touch screen. It walks you right through the programming process. Programming, it's the simplest programming ever that you've done on the thermostat. And again, if I have one here, I kind of show it to you.
So tell me about the boiler.
But so that the thermostat. Now the thermostat communicates to a boiler not by wires; it's wireless. We use a LoRa technology, which is kind of a low frequency version of Wi-Fi, and we use that because it goes through sheetrock and building materials very, very well. So the thermostat goes into a J box. The J box has 120 power in it. So usually you walk into a room, you typically have a light switch and a thermostat right above it. So you run 12 inches of Romex from one J box to the next, 2 wire nuts, and your thermostat is powered up, and then it's online wirelessly. And it communicates to a thing inside the boiler, which we call the Warmboard reset control. You may be familiar with outdoor reset, various ways of setting the boiler temperature.
So that's going to anticipate the heating load based on what the outdoor temperature is, right?
Yeah, but we don't do that. There is no outdoor sensor with this. We just look at our thermostats. Our thermostats feed us the data that we need to know to set the boiler temperature. And we ramp the boiler temperature up for speed of response when necessary. We ramp it down for energy efficiency where necessary. Think of it when you have a car, let's say it's a 200 horsepower car. Driving level on a freeway, you're doing maybe 20, 30 horsepower being used. You only need that 200 horsepower to pass.
Or to do burnouts.
Yeah, that thing's, donuts and to, climb hills and to pass cars. So the same thing is true for Warmboard. It's most of the time operating at its ultimate energy efficiency, but as soon as it sees that there's a big change in delta, it's going to ramp up. So we can return from vacation setback. We can go from 55 to 70 degrees in about an hour.
Wow. And that's
we can go from nighttime setback, 65-degree bedroom to 70-degree bedroom in about a half an hour.
Go ahead, Mike.
And that's a big thing with that we find if we have an slab system, you're not going to get that kind of response.
Right?
No, and I think that's actually, I think two of the big stumbling blocks are of people that know about radiant but don't really know a whole lot about it is that, one, they think that's the case. They think it's always got a slow response time. And they also have heard stories about people who've installed their own boiler systems. The plumber maybe isn't familiar with radiant heat, and it takes them a lot of commissioning to get a system that's evenly distributing heat throughout the house.
And this is a self-commissioning boiler, too, so you no longer need a radiant specialist. You no longer need to do... We do a heat loss and mechanical design for you when you buy the system. That's all included in the price. But you don't need to hire a separate contractor to do that. And the boiler itself is... it's a self-contained boiler room in a box. It sits about this high, about that wide, about that deep. It hangs on the wall. You hang it on the wall, which takes a few minutes. You connect it to natural gas. You plug it into 120-volt power. You have supply and return goes to your manifolds and a water feed from the city, and you're done. You can literally install an entire boiler room in about 1 to 2 hours, when it takes 1 to 2 weeks for most radiant specialists to do it.
The plumbers I know have very strong allegiance to respective boilers. They have a favorite brand, and it might be because their supplier stocks them, or they've had good success,
or
they're
buys
getting
them a round of golf,
or they're getting like loyalty points, like you get for the airline, right? You put some of these boilers in, you're going to get a trip to Hawaii at the end of the year. So do you have the ability to let plumbers choose their boiler?
They can choose any boiler they want to for the Warmboard comfort system, so long as it's ours.
So you have your own brand of boiler?
We have our own brand of boiler. It's actually, we make it in combination with, in alliance with HDP. We don't actually manufacture boilers.
Heat transfer products, for those of you who don't know, and they make very cool heating plants.
Yeah, and they have a really good new one out called the UFT, and we're based on the UFT. It's called Ultimate Fire Tube Boiler, I think. And
these are modulating, condensing.
It's a 97% efficient boiler. One of the things we like is it's got a 20 to 1 turn down, which means that
when you have low load, it can adjust.
It's got a modulating boiler, and you can turn it way, 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 way down. I like to actually run my radiant heat in my bathrooms in the summer, because I don't want to step on cold tiles. So we have a floor warming function that's part of our thermostat too. So if you just want to have just barely warm tiles and not heat the rest of your house, we can ramp down that boiler with that turn down rate, that modulation. And so it's this great, highly efficient boiler. We add an additional box to it and our own front cover to it because it's bigger. It now has expansion tank, the pumps, our Warmboard reset controls inside of it. And then it talks to the manifolds wirelessly too. So big labor.
And so there's zone valves on the manifold?
Oh yes. Mm-hmm. And a big labor cost in any radiant system is the electrician, because he's stringing 24-volt wires all over hell and creation, drilling zillions of holes through joists and
that's to power
studs.
8 or 10 zone valves.
Yeah. There's none of that.
Oh.
No, the manifold controller plugs into a 120-volt outlet, and that gives it power to run the actuators. And it communicates to the boiler wirelessly. Wow. And on top of it, this whole thing is a mesh network. So the Warmboard reset control, the thermostats, and the manifold controller, and then there's another component called the bridge, which allows you to connect to the internet and to operate this thing with your smartphone. So all of those 4 components are the suite, and all of them are individual nodes on a mesh. So if you get some, like maybe you're a dentist and you have an X-ray facility in your house and you got a lead wall, and it's not going to go through the lead wall. This will route it around through the mesh to make sure you always get communication.
So explain that to me. So the devices actually communicate with each other to continue the signal.
Yes, it's not merely what's called a star network, which is where you have a center unit and it communicates out from like that. Mesh network goes
any
all
number
around.
of ways.
Yeah, any number. It finds a way. So the whole point of this was to make it ultra simple to and fast to install. We wanted to get radiant specialists out of the business. No offense on them. We do a lot of business with those guys, but they're killing our business because there's not enough of them. And when supply is low and demand is high, their prices are very high. Any journeyman plumber can install the Warmboard comfort system. Any journeyman carpenter can install our panel. And so conventional tradespeople no longer need to be shut out of the radiant industry. Every licensed contractor has the wherewithal to do this kind of thing, and it's pretty simple. We'd always talk about it with our panel. Almost every time a carpenter uses it the first time, they're upset about it, because it's different. They don't
Because
like
you have to
different.
cut aluminum panels.
Yeah, they don't, they say, well, what's it going to do to my saw blade? Trust me, the aluminum will do less to your saw blade than the glue, the phenolic glue in the panel. But we call it the 5-panel aha moment. After they got 5 panels down, they decide, oh, it's just subfloor after all, isn't it?
Right.
And they get on with it. And the same thing is true for this boiler. I mean, we had this.
How much space does that need?
It's you can put it in a 2 foot by 2 foot utility closet.
Can you, this is sort of a side tangent, can you hook it, so can you use it for hot water domestic as well?
We elected to not go that route.
Okay.
And because my technical services manager, who's been in this business a long time, says, you know, when the heat goes out, that's a problem, but you can get out blankets and coats and
Electric space heaters.
and electric space heaters, and you can get by. When you don't have hot water, you're not taking a hot shower, and people are very upset about that. And he says, so separate if you tie your hot water to your heating plant, if one goes, both go. And so in my particular house, I have the Warmboard, we call it the warm source, is what we call the boiler. That's that HDP Warmboard collaboration. And then right next to it, I have an HDP on demand. So they're just side by side in my garage, and they work very nicely. It's really the best system I've ever had. I've had, because I'm the alpha house. I'm on
You test all this stuff.
I'm on the 3rd boiler system in my house, and my 4th water heating.
Do you put this
situation.
stuff in yourself?
Huh?
Do you put this stuff in yourself, or do you have a contractor?
I used to. I don't do it anymore.
Yeah.
I'm getting up in the years,
Yeah.
and I'm doing okay, and I like to hire people to do stuff these days.
Sure.
But yeah, I've been accused of being one of my old partners in business says that I'm so much of a do-it-yourselfer. If I could drill my own teeth, I would. I wrote my own patent. I built my own prototypes. I figured out how to stamp aluminum
That's why I
myself.
asked, 'cause you seem
it was
like
all
that
done in my
kind of guy.
garage.
Yeah.
That's a classic garage startup story, right? So. Anyhow, so that's the Warmboard comfort system. It is a suite of components. It's 4 components. There's a bridge that connects you to the internet. There's this very elegant thermostat, super easy, pleasant to look at, easy to program, wirelessly connects to your boiler. Boiler wirelessly connects to manifold controllers. All of it easy to program, easy to set, and because Warmboard uniquely draws every one of our houses, we do a complete set of documents for every house.
That's
we
cool.
know exactly how many zones, where the thermostats are going to be, etc. So you don't just buy a thermostat in a box. It's already been pre-programmed and addressed, and it has a label on it, and it's all color-coded.
Seems pretty cool.
And everything is color-coded. So
what's this all cost? And then we're going to get to Mike here.
Well, this is the beauty. I did this to drive costs down.
I know. So, give me a square foot price. I know you hate to do that.
No, I'll blurt it out here. You could get all the pieces and parts you need, less labor, for a 3,000 square foot house for about delivered, including freight, for about $12 a foot, approximately. So $12 a foot. Now,
Does that jive with what you pay for an HVAC system?
If for a radiant system, absolutely.
Yeah.
When you start figuring all the components,
this will be cheaper. This
it
will
would be
actually.
net. But if for what you're saying and all of the labor
Yeah.
that an ordinarily installer would have to do, you're probably saving a bit.
Yeah, so
overall.
we estimate it's going to be between $1, $2, and $3 a foot, depending on how efficient the contractor is to install the system. Let's pick $2 as a middle number. That means you're getting a radiant system for about $14 a foot. Radiant typically costs $15 to $20 a foot right now. So we've always been known for being the best. If you go on the internet and you see what people say about Warmboard, we always have had the best panel. But when people complain about us, they say, well, it's a little bit spendy. Well, there's a lot of aluminum on Warmboard. Aluminum, especially these days, is very expensive. And so we said, yeah, we're a little more, maybe $1 a square foot more than Gypcrete, maybe $2 a square foot more. We work so much better. Now we can say we're $1 or $2 less than Gypcrete, and we still work better.
What are you saying?
There's a lot more involved with Gypcrete than there is with putting Warmboard down.
Yeah.
I mean, you've got to set it up. You got to put the tubing down. You got to protect the tubing while people are working over it until the Gypcrete goes in. Then you got a couple of days while that's getting set, and you can't do anything. And then invariably somebody drives a nail through it because they can't see it.
Right.
Because you got to there's lots of complications. So.
I was in on a photo shoot in Greenwich, Connecticut, and they were actually pouring the Gypcrete floor, and all of a sudden I hear the guy screaming, it's because it was leaking around the toilet flange and pouring into the basement. And I just hear these guys start cussing.
It's one of the things when you prep for the gypcrete pour, you have to dam up your stairs.
Oh my gosh, it's
Any
a big
place
project.
a soil stack goes through a floor, you got to dam that up. So there's a whole lot of prep work. Otherwise, that stuff's pancake batter, runs everywhere.
Yeah.
And
so you were talking about 1.1/8 subfloor today with hardwood. What did you? I want to talk about that before we sign off.
We're not going to talk about that on the podcast today.
Oh, come on.
No, because I don't have enough information.
That's never stopped us from talking about stuff before.
No, there's more stuff about the flooring industry and the changes that are going to be coming up this summer for their installer's guide. So
can you at least just give us a rundown? You were talking about that, not like the details, but like
let's skip on the thickness and talk more about what most people are an issue with wood flooring,
please,
which is tar paper versus red rosin paper versus nothing.
Nothing, right?
With Warmboard, it's nothing.
So for those of you out there, is commonly you put this paper layer under the finished floor to decouple it from the subfloor.
Well, it's typically used as tar paper, and that's what's called for in their specification guidelines right now. And that was primarily thought to be a
vapor retarder.
Vapor retarder. So they didn't want the moisture to come up from underneath. Say you were a first floor over crawl space, and then you got cupping and buckling of the flooring. It's seasonal movement,
sure.
The moisture changes. Well, that was all written back in the 30s or 40s initially. And then just like laws that change of the codes, everything just gets a patch and a Band-Aid and a patch and a Band-Aid. And that's what they've done since then. So they've gone soup to nuts involving industry experts from the wood subfloor groups, from building scientists, from HVAC people, from all pulling as much information as they can into a repository, which is Brett's head, and figuring out what's going to be the best to make the flooring last long-term.
So there's going to
perform.
be a definitive installation manual for various widths of hardwood flooring we can expect?
We can expect that for the most part, we can put hardwoods right over subfloor if you're in over a conditioned space. So if you're conditioning a basement, for instance, or conditioned crawl space, which a lot of people do nowadays, then we don't need any underlayment at all. No tar paper, no plastic.
Is there any reason to put the tar paper there though to stop squeaks? Does the Wood Flooring Association say it helps?
It shouldn't be moving laterally and causing squeaks.
Yeah,
but it is one of the nice things about Warmboard is we tell people don't use it because the whole top surface of Warmboard is aluminum, which is a way better moisture barrier than tar paper or rosin paper will ever be. And so you will admit it. It's one of the steps you'll admit.
So when is this new document coming out?
Hopefully in August, they said.
And what are they going to call it?
The same thing it's called now. It's the installation guidelines, and
it's the National Wood Flooring
Association.
NW.
Yeah. And one of the things, and I said right to the gentleman, I said, so this is really going to upset a lot of people. There's going to be a big change, and he goes, yeah. Because there'll be old school guys that are going to want to keep doing it the same way, and it may not be the best way.
In the industry, people do stuff that works for them, right? Yeah. And they are not going to want to change. I've never had a problem with this. Don't tell me not to do it anymore. And
they got a lot of they're getting the manufacturers all on board because there's so many wood mills and manufacturers, plus composite engineering flooring as well that utilize hardwoods
over plywood.
So all of those are going to be affected by this, and then they're going to be using climate zone maps because they'll be micro adjusting the installation for moisture content and so on.
More fasteners?
We didn't get that far in our discussion. I only spent 45 minutes there. I only spent 45 minutes with him, so I couldn't get the whole download. We're going to stop there later, and we can talk to Brett some more. But so now we're going to have not only climate zones thermally, climate zone 1, 2, 3, 4, 5, 6, 7, 8. We're also going to have horizontally with moisture, depending on
coastal,
coastal environments versus moderate climates versus dry climates. So all of that's going to impact how we install flooring. So it's not a one-size-fits-all anymore. We're going to have to really dial in to our climate on how we install things. So it's going to take the installers really thinking a lot more about, they'll each get familiar with their local region.
Right, where they
but
are.
If you're moving to a different region, you're going to have to
Redo.
reread what the installation guide calls for there.
So you almost think that the local distributors are going to be a big part in, like, hopefully educating some people.
And hopefully that'll be the case, because a lot of guys don't hear about this. It's not like you get a notice in the mail when guidelines like these change.
So
Yeah.
to be honest, like, of all the building products, that go into a house, like, hardwood flooring is a very simple product. You would think that there's not too much to know.
Oh,
it's
man.
way more complex.
Yeah,
than
I
you
believe it.
suspect.
Yeah.
It is so
We
complex.
deal with it a lot.
Everything
a
is
lot.
more complex
Right.
than we expect.
I get at least 6 calls a year to come out and investigate problems for homeowners. Cupping, buckling, shrinking.
Squeaking.
Not so much on the squeaking, actually.
What is it with you and the squeaking?
Yeah.
Patrick?
I have a squeaky floor. So I have a crappy house, and its floor is squeaky. Whoever put it down did not use enough nails.
I have an antique wood floor in my own house, reclaimed wood, and they're old barn boards that they just basically hand sanded them very lightly. And when I was starting to nail them down, it was using the old cut nails to do it traditionally. After a while, I just took my framing nail and nailed it down. The squeaks are part of the ambiance of living in a house which is designed to look...
The
Exactly,
charm.
it's the charm.
I don't find it very charming when my 12-year-old comes out of his room and wakes me up because the floor is going...
Yeah, but you know what?
But you know
when
what he's doing.
16 years old, he tries to sneak out of the house.
Yep.
He's got a ground level window in his room, so there's no hope
yeah,
of catching
right.
You
him
have to
doing
make that
anything.
squeaky.
Yeah, I'll have to screw
Pull
it
the
shut.
jam liner
I'll
off.
screw it shut.
So Mike, we were just talking a minute ago about, like, how are people going to learn about this stuff? Because, like you said, you're not going to get a letter in the mail if you're a contractor saying you're doing your flooring wrong. But we're all involved in social media, especially Instagram lately, where we see every single day a lot of our core people in our audience out there sharing the information, showing what they're doing on a daily basis. And I'm wondering if, we were saying a generation ago, you did stuff based on how your grandfather did it. I wonder if this new generation is going to be more agile.
I've been having fun with Instagram and other social media the past year because I was a Luddite up till that point, being old. But I love it and I hate it. I love it because you get the immediacy, you can get information out there, I get direct contact with
But
other
nothing's vetted.
contractors. Well, it's not, the vetting part's part of it, but the other part is it's almost like Snapchat. Even though it's still there, you can't sort it, you can't re-find it.
Yeah.
So say we post later on the Fine Home Building website, we do an Instagram thing about this new wood floor guidelines coming out. In 3 days, it'll be buried 6 layers under.
Yeah.
And who's going to see it? So it's like if you don't catch it right away, you're going to miss it. There's more legs on websites. It lasts a little longer. But, yeah, it's like how do you get the information out in a way that a mass audience hears it and it gets... I think the distributors are really going to be the way, but they're not always... I know when I go to the supplier that I get my hardwoods from, they don't ever tell me anything. They say, what do you want? They take my order. They fulfill it. They say, oh, do you want all these extra add-on things? You got your nails, you got your underlayment, you got this, that. You got your finishes, and I'm gone.
Yeah.
They're not going to come out and
Yeah,
tell
all they
me.
want is a quick sale, and why waste any more time?
And there's a lot of misinformation out there. As long as we're on hardwood here, because that's something near and dear to my heart. We always used to tell people, because we were told to do this, that you should get your planks on site several weeks before it and acclimate.
And that's just not the right answer.
And that is exactly the wrong answer,
Yes.
because you could get your planks come in from the mill at, let's say, 8 to 9% moisture content, which it typically is. And if you're in Boston in August and you were to sticker those out,
It's going to grow to 15%.
They will go to 13, 15%.
Right.
And then when you nail it down, you're going to get shrinkage, cuppage, and warpage.
And
I was talking to Brett, by the way, because we work with NWFA.
Sure.
We're on their Radiant focus group. And I was saying, you guys need to start telling all your manufacturers to hermetically seal their planks from the mill.
So you're suggesting that they...
And only break them out of... you can put them in an aluminized Mylar bag, just like potato chips come in, and that seals it out of moisture. and you could make sure that you could order for a particular region.
You'd
say,
have to do it
I
by
want
region.
6%,
Yeah.
or I want 8%, or whatever. You ordered for, if you're in Arizona, you want about 5 to 6%. If you're in Massachusetts, probably 8 to 9%. And out here in California, we like
should
about 6 to 8%.
tell folks what you're talking about. So,
Well, wait, let me just say one thing about that, though. It's like, it sounds like a big deal, like, who would bother to divvy it up that way? But there's a lot of time and labor and lost work time.
We have to explain why you do this, right?
Yeah.
So you want to adjust the moisture content of the wood so it's in a sweet spot between its lowest moisture content and its highest. So depending on what you pour the floor down, if you let it acclimate, it's going to either have less moisture than is optimal or more. And so your suggestion is that you could order your kiln dry to the appropriate moisture content for the region and then keep it there.
And you know what region you're shipping it to?
Right.
So everything that gets shipped to the West Coast should be 6 to 8%. Everything that gets shipped to the South West should be.
That's freaking brilliant. What did they say about that?
Yeah.
They were saying, well, it'd be expensive.
Well,
and they said it's expensive to have flooring failures.
It would probably cost $1 or $2 a bundle.
Yeah.
Yeah, it might add 3 to 4 cents per square foot to the hardwood cost, and it's. I couldn't believe and it was the good old boys. My grandfather didn't do it, so why do I need to do it?
What do you think of that idea, Mike? I think that's pretty smart.
You know what? If they could do it, it would be genius. But
they know what moisture they kiln dry this stuff.
Right.
So when it comes out of the kiln, they know exactly what it is.
Yeah.
And they could just put it in a nice, the same kind of bag you put potato chips in, and put a little stamp on it.
He's starting a third career.
I mean, they already put it, if you got narrow oak flooring, it already comes in a container anyway, so why not just make the container out of a different material?
Yeah.
I think that's pretty smart.
Yeah.
I'm on board.
Yeah.
I'm on board, Terry.
Yeah. And quite frankly, I'm not waiting for the NWFA to make that decision. No offense to those guys, nice people, but it's an NGO. They operate just like the government.
Yeah.
And there will be some entrepreneurial.
Someone's going to figure that out.
Hardwood flooring people that say, hey, we want to buy our flooring because we hermetically seal our planks at a known moisture content
optimized for your climate.
your region.
I mean,
and
that's
you don't
a
need
thing.
by the way, it also saves the contractor time because he doesn't have to take time to bust it out of the bundles, sticker it, wait 2 or 3 weeks for it to get to be the wrong moisture.
Well, that's what I was getting at.
Yeah.
I was like,
it's labor savings, it's better product, everything wins.
Why don't you start a new business?
Oh, that's just what I need to do. That's just what I need to do.
Maybe you need a partner.
Yeah, exactly.
And you already have the technical background, and you got the idea.
Yeah, and to your people that are on here, I mean, wood is a natural product. It's a hygroscopic product. When you fell a brand new green tree, it's about 26% moisture. And then we keep driving the moisture down and down and down. It's never 0%. Even in the desert, it's 5 or 6%. And the dimension of the wood is directly related to its moisture content and whether or not you're going to have
gaps between boards,
gaps between boards, or cupping, or crowning. The opposite of cupping. Or any number of other failures that happen with wood. I'll tell you the other common wood. This is another dark little secret. Engineered wood gets face checking because they make this.
So tell me, what does that mean?
Well, 50% of all wood that's made these days is engineered wood.
You mean hardwood flooring?
Yeah, hardwood flooring, which means that they usually have some form of plywood underneath the
wear layer.
A wear layer that's typically maybe 1/8 of an inch, 3/16 on the better brands, 16th on the less good brands.
That's bad.
Yeah, exactly. And so the theory is that plywood, because you have 0.90s of orientation of fibers, that it doesn't expand and contract much, and that's true, but the face does. And so if it's glued to a stable surface and it gets dry in the winter, like in Boston, you got the heat on, it'll go down to 5%. It's worse than Tucson in the winter in Boston when you got the heat on if you don't have humidification. And so what those fibers on the facing veneers are
apart.
They're pulling apart, and they get little, what's called face checking, little tiny cracks and fissures in the surface. And it's endemic to the engineered wood business. The reason why I recommend to all my clients regular planks. Old-fashioned regular planks. Yeah,
right?
Yeah, 2 1/4 inch.
Yeah.
That's what I have in my house. It expands and contracts gracefully. You're going to get a little gapping in the winter. It's minor, maybe a business card
And the gaps get bigger with the width of the plank, right?
Yeah, exactly. And it's part of the charm of hardwood floors. We're used to seeing it. You've never seen a hardwood floor that didn't have some gapping.
Yeah.
It's always been good.
Unless they're 100-year-old oak flooring.
It's quarter sawn.
It's quarter sawn with the old growth lumber. Those stayed stable, but nowadays not
exactly.
so much.
But in any case, so this is one of my big bugaboos because people are very nervous about their hardwood on top of radiant.
Sure.
And we would tell people it's not the heat in the radiance that's the problem. It's the ambient humidity. And if you do humidity control, you'll have a very stable floor on top of your radiant floor. But if you're going to go from 80, 90% in the summer to 5% in the winter, I don't care what kind of heating system you have, whether it's forced air, wall radiators.
Yeah, you're going to have movement in the floors.
You're going to have movement. And so if you want to have your floors look nice, make sure that you install them at the right moisture content, which is hard to do. In my particular case, I've redone my house a couple times too, because I'm that kind of guy. And when I first put hardwood in, I did the stickering thing, and I ended up with some significant gaps in my floor. And then I redid a back room and a kitchen. And this time I brought the hardwood in, and there's a guy down south of me that's got a kiln. And they said, take it to 6%. I wanted exactly 6%. And as soon as it was 6%, I didn't wait for it to accidentally get to be the right moisture. I put it in a kiln, took it up to my house, nailed it down right away. My floor is dead flat, no gaps, summer, fall, winter, spring. It's just beautiful. And it was just getting the right moisture content.
It's a good way to do it. I mean, how many contractors and flooring installers think to bring it to their load of flooring to a local kiln to get it to the right moisture content?
Yeah.
They're usually counting on just the ambient air and
Or
temperature and humidity.
Accidentally,
Or
maybe
luck,
by
yeah.
chance, end up the right moisture content, which more often than not it does not.
It's largely luck, I would say. And if you install it at the right time of year, you have a better chance of success. But if you're on the superhuman summer or the dry winter, it's going to likely have problems. Well, unfortunately, that is all the time we have today for our live recorded podcast from the IBS show floor. I want to thank Rob, Mike, and Terry for being here with me. And thank you all for listening, and happy building.